Welcome. So in this segment, we'll be talking about oxidation and reduction reactions. This first comes up in the context of aqueous solutions, but it happens in other situations as well. So we're going to talk a little bit about the general process. So learning objectives here. Let's switch over to tablet. So the learning objectives here, we want to define oxidation and reduction. We want to calculate oxidation numbers in a molecule, recognize when oxidation and reduction are occurring in a reaction, and identify the oxidizing and reducing agents in a reaction. Okay, so why are we interested in redox reactions? Well, it's useful for refining metals. Refining metals is usually a matter of reducing them from their initial state, which is usually oxidized. Preventing corrosion. This is quite important because corrosion reactions are oxidation reduction reactions, going from a pure metal to an oxidized state. Understanding fuels and combustion. A lot of fuel and combustion is oxidation. And making better batteries. Redox reactions are frequently used to drive batteries. So these are all reasons we want to be able to understand what's going on in redox reactions. This will become particularly important later when we're looking at electrochemistry. Okay, so oxidation. So oxidation, the original definition was something reacts to gain oxygen. For example, iron reacting with oxygen produces ferric oxide. So this is an example of clearly an iron gaining oxygen and resulting in a compound that's oxidized. The newer definition that is more general but describes all of the other oxidation reactions is that it loses electrons. Fe2O3, it's an insoluble ionic compound at Fe3 plus and O2 minus. So somehow iron lost 3 electrons in order to become the iron 3 plus ion. So in this case, it has oxidized, the iron is oxidized, it has lost electrons. So oxidation is the loss of electrons. Reduction, as you can imagine, is the original definition was loss of oxygen, reducing the amount of oxygen. So in this case, if we have iron oxide reacting with carbon, which is sort of the basis for a lot of purification of iron from iron oxide ores, from the smelting, you get out iron and CO2. The oxygen is taken from the iron to the carbon to produce carbon dioxide. So iron in this case is purified by loss of the oxygen. So this new definition is, rather than looking at just the oxygen, looking at something more general, what's happening in the iron. So the new definition is that the iron gains electrons because Fe3 plus, the ion that it is in Fe2O3, becomes Fe. It picks up those 3 electrons. So in this case, reduction is gain of electrons. It's reduction of oxygen, but it's gain of electrons. There's a simple mnemonic for this. Oxidation is loss, reduction is gain, oil rig. So remember that, keep that in your mind. We're trying to remember oxidation, which way are the electrons going? Oil rig, oxidation is loss, reduction is gain. Oil rig, oil rig, that should be square. There's a little oil rig there, yes, with oil coming out, yay. Oil rig, oxidation is loss, reduction is gain. Okay. So where do the electrons go? So again, so we have a reduced compound A. It's reduced, it has more electrons, and an oxidized compound B. And in the reaction, those electrons are passed from the reduced compound A to B so that B is reduced. So the number of electrons remains the same. They're just moving from one molecule to another molecule. Again, since it's annoyingly confusing, oil rig. Being oxidized means losing electrons. Being reduced means gaining electrons. Iron is oxidized to Fe3 plus, zinc 2 plus. The zinc ion is reduced to zinc. It has gained electrons. Okay, so a question here, oxidation reduction. How many electrons in total are transferred in the above reaction? And which molecule is oxidized? Which molecule or atom is oxidized? So I'll pause. Okay, coming back. So in this case, sodium chloride, we know is, the sodium chloride, the sodium ion in sodium chloride is +1, chloride is -1. But if we look at just sodium solid, elements do not have an excess of electrons. And so, sorry, there we go. Elements don't have an excess of electrons, and so therefore they have exactly the right number of electrons. We could say that they have 0 excess electrons. Chlorine indeed also has 0 excess electrons. So therefore, an electron has moved from sodium to chlorine. So therefore, now there's 2 sodiums because both of the sodium, there's 2 sodium metals, and they each lose an electron. So there's 2 electrons that have moved. Which molecule is oxidized? Oxidation is loss. So therefore, the one that lost an electron is sodium. So it's sodium that has lost electrons, and 2 electrons are transferred from the sodium, from the 2 sodium atoms to the chlorine gas to form the 2 chlorine ions. Okay, so oxidation is lost, sodium is oxidized here. Even though there's no oxygen, under the now standard definition, oxidation is measured not in terms of the oxygens gained or lost, but the electrons gained or lost.